Welcome to another video from the University of Rhode Island Physics Department, and in this video today we're going to be going over the Lenses and Mirrors lab. So the image formation by lenses and mirrors is governed by an equation that relates the object distance, which we call P, the image distance, which we call Q, and the focal length, which we call F. It is the same equation for the mirror and the lens, and that equation is 1 over F equals 1 over P plus 1 over Q. For the setup in this experiment, the object and image distances are positive and equal to the distance from the mirror or lens to the object or image respectively. In this experiment, you'll be measuring the focal length of mirrors and lenses by locating the image of a light source and measuring the object and image distances. Alright, so to perform this experiment you need just a few different materials. First up we have our metal track with a built-in meter stick. We have our light source off to the side with a crosshair pattern. Off to the end we have a white backdrop so we can see any images that get formed. And in the middle we have either our lens or our mirror. So for the first part we're going to be investigating the convex lens, which has a known focal length for us. So off to one end we do have our light source with the crosshair pattern, and to investigate the focal length what you're going to do is move your lens along the track until you see off on the end the crosshair pattern come into focus. That would indicate we've found the focal length of this mirror based on where the image distance and the object distance are. Your image distance would be from your lens to where the focal point shows up over here, and your object distance would be from your original light source to your lens. For the second part of the lab, we've now switched out our convex lens for just a simple mirror. And instead of our white backdrop from before, we now have this little half screen in the middle. Because with a mirror, the light does not travel through, it's going to bounce back. So just like in the first part, we're going to reorient these until the image from our crosshairs appears on the back side of our half plate here. So just like before, you move it around until that image comes into focus, albeit it'll be a lot smaller this time, and we'll add an image there so you guys can see what it looks like. The major difference here is that your image distance here, so there's a little bit more that goes into calculating image distance here. Your object distance is still the same as before, it is just from your light source to your mirror. But aside from that, you can still use the same lens equation to figure out what the focal distance of this mirror should be. So now that you've seen how the data is collected for this experiment, you would then go and use the image and object distances that we've recorded for the lens and the mirror to then see if we can recreate and calculate what the focal length of each should be.